The world's water. Objectives. The aim of this lesson is to introduce the global concept of water, its importance and distribution. The objectives of learning this module are to highlight the following: importance and properties of water, presence of water in all spheres of the earth, the cyclic movements of water, the nature of water present in various reservoirs, the concept of water balance equation, the quality aspects of water. After attending this module, the learner will be able to explain about the distribution of global water masses, inventory of the reservoirs of water, and the importance of water balance concepts on the earth. Introduction. Water is the most precious gift of Mother Nature. Water is used for drinking, domestic purposes like cooking, washing, gardening and cleaning operations, industrial processes, and agricultural activities. Today, water has become a valuable commodity to mankind. Water has economic value. Without water, there can be no life. It is a basic substance occurring as solid, liquid, and gaseous states. Earth is probably the only planet containing plenty of water on its surface. The growing concern of environment demands more insight into the world's water resources. Water is one of the fundamental resources on the earth. Water is essential for all other life. It plays a major role in all aspects of human life. Hydrology is the scientific study of the origin, occurrence, properties, distribution, and effects of water on the earth's surface, in the soil and in the underlying rocks, and also in the atmosphere. The subject of hydrology is central to several concepts in physical, chemical, and biological sciences and engineering applications. It is founded upon other sciences like meteorology, geology, agricultural physics, and chemistry and botany. Understanding of the world's water masses as a part of the global segments is necessary for managing these resources. The world's water masses are the major reservoirs involved in hundreds of natural processes happening on the earth. These masses are fully under a dynamic condition. What is seen in a day may not be there in the next day in that form or shape or condition. The world's water is an interesting topic to learn. Water is available everywhere. Water is unevenly distributed in almost all parts of the world. Due to its uneven distribution and availability, it is to be managed and properly used for a long-time sustenance of life on earth. The increase in population and human activities demand for more use of water. Shortage of water is observed in some parts of the world. Water scarcity, water pollution, drought, desertification, and famine all are serious concerns of life on earth. The challenges of managing this resource require proper water education, training, and public awareness on water resource management. As a mass, water is not restricted to any one part of the earth. Water exists in all segments of the earth. The origin of water on earth dates back to several million years. In the early history of the earth's formation, around the time that the earth's crust began to form, severe volcanic activity released lots of volatile gases, including water, from the underlying mantle. These volatile gases made up the early atmosphere and oceans. It is thought that almost all of the water that we find in the oceans, lakes, streams, atmosphere, and the subsurface today was outgassed at this time. This water mass has been cycling and recycling all through these centuries. The connate water, fossil water occurring in deep sedimentary rocks, and the magmatic water emanating from the deep mantle are the major evidences for such origins and evolutions. Now, water exists in all the environmental segments of the earth. It is available as water vapor in the atmosphere, as ice caps, as soil water and groundwater in the lithosphere, as surface water in the hydrosphere, and finally, in most of the components of the biosphere. Water is the most common substance on earth. Every living thing consists of some amount of water. Fruits, vegetables, and poultry contain plenty of water in them. Water is a unique substance. Water has a large number of interesting properties. These make it an ideal medium to support life. Water is called as the universal solvent due to its extraordinary ability to dissolve a large number of naturally occurring and man-made substances. Water's melting and boiling points make it possible for all three phases to exist on our planet Earth. Water is also lighter when it freezes, so that it floats. If water sank, then the bottom of our oceans would be solid. Under such circumstances, we would only have a thin layer on the surface that would only be liquid. There would be far less global ocean currents, and many of our nutrients would be locked up inside. Survival of global life would be much more difficult if these properties are not possessed by water. The water molecule is also polar, enabling it to dissolve and transport a wide variety of chemicals and mineral substances. Water has the ability to dissolve many organic and inorganic substances in more quantity than any other liquid on earth. It has the highest heat of evaporation than any other liquid. Huge amounts of heat energy are required to evaporate even small quantities of water. Due to this high heat capacity and the presence of water on all parts of the earth, extreme fluctuations in local temperature is prevented. Global climate is controlled due to the properties of both water and air. Inherent properties of water. Water has the following inherent properties: transformation from liquid to vapor due to evaporation, transformation from vapor to liquid to solid through freezing, ability to flow downwards due to the action of gravity, ability to flow overland on any slope, ability to move due to the action of wind when it is in vapor form. Characteristics of water. Water can be a solid, liquid, or a gas. Water has very typical physical and chemical characteristics. Water has the tendency to break down into hydrogen and hydroxyl ions. This process is known as dissociation. The ability of water to conduct electrical charges is yet another property. Similarly, water has the ability to conduct heat. Water has a greater heat capacity than other substances except ammonia. Water's surface tension is also extremely high. The specific properties of water acting on these circulation are specific heat and latent heat, pressure, capillary forces and osmotic forces, density or specific gravity, unique melting point and boiling point, compressibility and viscosity. Pure water, H2O, is clear and colorless. It is tasteless. It has no smell. At 1 atmosphere, it has a melting point of 0 degrees centigrade and a boiling point of 100 degrees centigrade. Pure water has a density at 4 degrees centigrade of 1.00 grams per cubic centimeter. Water is a polar molecule and highly cohesive. The polarity of the water molecules results in high surface tension and high solvent ability. It is due to this fact that water is considered to be the universal solvent. One of the most important physical properties of water is its expansion upon freezing. Water increases in density until a temperature of 4 degrees centigrade is reached, after which it slowly expands until at 0 degrees centigrade upon solidifying, it expands about 10%. After solidification, water again contracts, that is, increases in density with decrease in temperature. Typical properties of water. The capillarity of water rising up through capillary tubes is yet another property of water. This property helps the plants to get water from the soil matrix along with nutrients. The dissolving ability of water is a major factor for several environmental, geological, hydrological, and other processes. Water can dissolve many substances. Water can dissolve mineral species present in hard rocks, soft nutrients, and also the waste food materials that are consumed by people and animals. Water has the ability to flow under the influence of gravity. Water can also exert hydrostatic pressure. The density of water is an important property. Due to the dissolution of salts and minerals, the density increases. This in turn increases the hydrostatic pressure of water. The hydrosphere. The term hydrosphere refers to the sphere of water on earth. It is derived from the Greek word hydor, means water, and sphera means sphere. It refers to the water on or surrounding the surface of the globe. It is the segment that includes all forms of water distributed over atmosphere, lithosphere, and biosphere. When we think of the planet Earth, both the land and oceans come to our mind. Land makes only a small part of the world's surface, but water makes up to 70% of the Earth's surface. Water is not only present in seas and oceans, but also as ice caps, glaciers, rivers, lakes, reservoirs, soil water, groundwater, and atmospheric water vapor. Similar to the variation of pressure and temperature with reference to altitude in atmosphere, there is a remarkable variation in the physico-chemical properties with reference to the depth of water masses. The average annual rainfall over land amounts to 119,000 cubic kilometers. Out of this, some 74,000 cubic kilometers of water gets evaporated back into the atmosphere. The remaining 45,000 cubic kilometers of water flows into lakes, reservoirs, and streams, or infiltrates into the ground to replenish the subsurface formations. This represents what is traditionally known as the water resources of the world. Not all of these 45,000 cubic kilometers are accessible for human use. This is due to the reason that part of the water flows into rivers and during seasonal floods. An estimated 9,000 to 14,000 cubic kilometers of water alone may be economically available for human use and consumption. The actual annual withdrawals of water for human use amounts to about 3,600 cubic kilometers. Distribution of water on Earth. The Earth has about 1.386 billion cubic kilometers of water. In this, about 97% lies in the form of seas and oceans containing salt water. More than 2% exists as ice caps and glaciers, and about 1% is spread in the form of rivers, lakes, groundwater, and water vapor. Almost 97% of the water existing in the hydrosphere is distributed as seas and oceans. These are all saline water masses. They are not suitable for direct consumption like drinking, cooking, and for industries and irrigational purposes. Only 3% of the water available on Earth is fresh water. If we look at the further distribution of fresh water alone, almost 66.7% is locked up in the form of ice caps and glaciers. About 30.1% is existing below the surface as groundwater. The surface water, which is directly available on the land surface, is only 0.3%. The rest 0.9% are existing as water vapor and soil water. The surface water available as 0.3% is shared by lakes, swamps, and running water as rivers. In this, a very small proportion exists as biological water. If all the Earth's water are put together in the form of a sphere, then the diameter of that water ball would be about 1385 kilometers. If we consider the volume, it would be a very small ball in front of the total mass of the Earth. Inventory of world's water. If we look at the inventory of world's water distribution, the oceans and seas contain about 1,370 million cubic kilometers. Ice caps and glaciers contain about 24 million cubic kilometers. Groundwater constitutes almost 60.0 million cubic kilometers. Rivers, streams, lakes and swamps contain about 0.2812 million cubic kilometers. Soil moisture constitutes about 0.083 million cubic kilometers. Water vapor contains about 0.014 million cubic kilometers, and the biosphere contains about 0.0011 million cubic kilometers of water. All of these water masses are called as water reservoirs of the Earth. On an average, water is renewed in rivers every 16 days. Water in the atmosphere is completely replaced once in every 8 days. The replacement is slow in lakes, glaciers, and in groundwater systems. The reproduction rate also varies from one reservoir to the other. It is highest for the water present in the atmosphere and lowest in the ice caps and glaciers. Residence time of water in major reservoirs. The residence time of a water reservoir within the hydrologic cycle is the average time a water molecule will spend within that reservoir. It is a measure of the average age of the water in that reservoir. Residence time can be estimated in two ways. The more common method relies on the principle of conservation of mass and assumes that the amount of water in a given reservoir is roughly constant. In this method, the residence times are estimated by dividing the volume of the reservoir by the rate by which water either enters or exits the reservoir. Dating the age of water using isotopic techniques is the second popular method. The following table shows the approximate residence time of water in major reservoirs. The residence time of water in the atmosphere is about 9 days before condensing and falling to the earth as precipitation. Deep groundwater may stay over 10,000 years beneath the earth's surface. The ice from the Antarctica has been estimated to be of the age of 800,000 years before present. Country-wise water resources. According to the Food and Agriculture Organization (FAO), the total water resources in the world are estimated in the order of 43,750 cubic kilometers per year. This is distributed throughout the world according to the patchwork of climates and physiographic structures. At the continental level, America has the largest share of the world's total freshwater resources with 45%, followed by Asia with 28%, Europe with 15.5%, and Africa with 9%. In terms of resources per inhabitant in each continent, America has 24,000 cubic meters per year, Europe 9,300 cubic meters per year, Africa 5,000 cubic meters per year, and Asia 3,400.1 cubic meters per year. At a country level, there is an extreme variability in these resources. The 10 poorest countries in terms of water resources per inhabitant are Bahrain, Jordan, Kuwait, Libyan Arab Jamahiriya, Maldives, Malta, Qatar, Saudi Arabia, United Arab Emirates, and Yemen. In the large countries, water resources are also distributed unevenly in relation to the population. In addition to spatial variability, there is a high variability in time within the year or among different years. 33 countries depend on other countries for over 50% of their renewable water resources requirement. They are Argentina, Azerbaijan, Bahrain, Bangladesh, Benin, Bolivia, Botswana, Cambodia, Chad, Congo, Djibouti, Egypt, Eritrea, Gambia, Iraq, Israel, Kuwait, Latvia, Mauritania, Mozambique, Namibia, Netherlands, Niger, Pakistan, Paraguay, Portugal, Republic of Moldova, Romania, Senegal, Somalia, Sudan, Syrian Arab Republic, Turkmenistan, Ukraine, Uruguay, Uzbekistan, Vietnam, and Yugoslavia. Cyclic movement of water. The world's water is not in static condition. It moves from one reservoir to another reservoir and also from one state to that of the other. Water is in constant motion and circulated between all these reservoirs. The Earth's water moves from the oceans to the air, air to the land, and land to the oceans again and again. The sun's radiant energy evaporates oceanic waters into the atmosphere as water vapor. This moves towards the land and falls back as rain, snow, and sleet. These slowly flow over land, fill up the lakes, swamps, and streams. A part of these water masses percolate inside the ground and join the groundwater. The other surface water masses may flow towards the sea and are subjected to evaporation and transpiration processes. This endless circulation of water masses among these reservoirs is known as the hydrologic cycle. The hydrosphere interacts with the atmosphere and lithosphere mainly through the water cycle. Natural reservoirs and conduits. Much amount of water on Earth gets circulated within the lower part of the Earth's atmosphere. In this region, water vapor is transported in all directions. The net effect is the movement from sea to air and from air to land. The wind and pressure belts play a significant role in this movement. The shape, type, size, and location of the reservoir play a dominant role. This also varies above the surface and below the surface. Water flowing in streams ultimately reach the lakes or seas faster than the water which is flowing below the surface. The water entering into a lake after a rainfall may be locked up from the movement for several days and months. Similarly, the water percolating below the rocks through deep fractures in the Earth's crust may also get locked up for many years. Some fossil waters entrapped under geological beds of rocks may be of several thousand years in age. It is also an important fact that the age of the water residing in the oceans may be of several million years. The hydrologic cycle. The hydrologic cycle involves a set of processes that are everlasting processes. The components of the hydrologic cycle are precipitation, infiltration, surface runoff, transpiration, groundwater base flow, interception, evaporation from free water surfaces, condensation, evapotranspiration. The hydrologic cycle forms the central concept in all the scientific studies of water. Human pressures at global to basin scales are substantially modifying the global hydrologic cycle. It has severe adverse impacts on its interconnected aquatic ecosystems, both freshwater and marine, and therefore on the well-being of people who depend on the services that they provide. Components of the hydrologic cycle. The dynamic movements are coupled with changes in the states of matter from liquid to vapor, vapor to solid, and liquid sequences. The movements are also not uniform. There are varying rates and there are many short circuits in the cycle also. Sometimes the residence time of water in a reservoir gets increased due to stagnation of water in that reservoir. The routes of movement also varies. Some masses follow the aerial routes and some of them follow the subterranean or subsurface routes. Much amount of water that are flowing over the land reach the seas and oceans above the surface. Groundwater also moves under the ground and follows the subsurface path. Some amount of surface water may leave directly into the atmosphere through direct evaporation from surface water bodies and also through transpiration by vegetation. The rainwater falling on the leaves of vegetation also may get evaporated back into the atmosphere within a short span of time. This is called as interception. The water of the snowfields may get evaporated directly into the atmosphere. It is called as sublimation. The rates of movement of water and the quantities of water involved in the cyclic process are the major aspects involved in the hydrological sciences. The water vapor that are accumulated as condensed clouds of the atmosphere get precipitated in the form of rain and snow and fall on the earth's surface in liquid or solid forms. The rainwater flows as surface water over the land or infiltrates into the ground. No beginning and no end. Since the world's major amount of water gets stored in the seas and oceans, it is quite natural to assume that the hydrologic cycle starts from oceans and from evaporation. Similarly, the precipitated rainwater may also be presumed to be the starting point of hydrologic cycle as it comes from the atmosphere directly as the primary source. Though we feel that the hydrologic cycle begins from evaporation or precipitation, it has no beginning and no end. It is a never-ending cycle. It has endless circulation. Factors controlling hydrologic cycle. Several factors control the circulation of water on the earth. The following are the major factors controlling the hydrologic cycle. Nature and application of energy that promotes circulation. Inherent properties of the water, air, and other masses. Structure of the natural reservoirs and their conduits or channels promoting movement. The Earth's gravitational attraction, which is responsible to activate the flow. The hydrologic cycle has a direct link with the monsoon cycle of a region. Any drastic climatic variation or climatic change that are occurring on the globe will have a direct consequence on the circulation pattern of water on the earth. Source of energy. The principal source of energy which mainly drives the circulation process in the hydrologic cycle is the sun's radiant energy. It has the ability to transform water from one state to the other. All the mechanical and chemical works are also controlled by the radiation. Solar energy can raise the temperature of water, air, soil, and promote various processes at different altitudes and latitudes. Adolf F. Meyer, in the Elements of Hydrology, explains the role of solar energy for water circulation. The sun's energy vaporizes the water from the surface of the earth. The vapor thus formed is lighter than the dry gases of the atmosphere, and hence it tends to rise. Aided by the convection currents, the water vapor moves from place to place and upward through the air. On rising, it encounters a rarefied atmosphere and expands. The energy required for the work of expansion is drawn from the air itself, resulting in a cooling and ultimate condensation of some of the vapor which falls to the earth again as rain. The precipitated water then starts on its way back to the ocean. Some of it is lost through evaporation, and some is used by growing plants. The most complete conservation of water can be secured only by its fullest utilization for so long as the sun shines. Distribution of water in various reservoirs. Water in the world's oceans. As seen already, 97% of the world's water lies in oceans. Oceans have two inputs. One is the direct precipitated rainfall, which accounts for about 90%, and the other one is the runoff from the lands, which accounts for about 10%. Oceans have only one output as direct evaporation. The residence time of water in the oceans is about 3,000 years. The waters which reside near the surface of the ocean have shorter residence time than the water of the deep ocean. The deep water of oceans may have the residence time of hundreds of thousands of years. Only the water available at the surface of the ocean is involved in evaporation. Ocean water contains about 35 grams per liter of dissolved salts, making it unfit for drinking and other purposes. Distillation is the only way of making fresh water from seawater. Every day, the sun evaporates millions of metric tons of water from the oceans. The distribution of water in the world's oceans are as follows. Oceanography is the branch of science that is dealing with the physical, chemical, geological, and biological features of the seas and oceans. Oceanography deals with salt waters, whereas limnology, Greek limn, lake, usually deals with fresh waters. Water vapor in the atmosphere. Moisture exists in the atmosphere as an invisible form called as water vapor, as liquid in the form of water molecules, as solid in the form of snow or ice. The amount of water vapor present in the atmospheric air is called as humidity. The amount of water present in the atmosphere volume-wise is equivalent to the volume of water flowing through the rivers all over the world. If we look at the rate of exchange between the water in the atmosphere and on the earth every day, it shows that approximately 2.5 millimeters falls as rain and about 2.5 millimeters of water gets evaporated from the surface. The average residence time of water in the atmosphere is about 10 days. It is also found that there is a complete exchange of atmospheric moisture 40 times a year. Water in rivers and streams. The rivers all over the globe seem to be primary reservoirs of water. The volume of water in the earth's streams is very small, accounting to only 0.001% of the total world's water. The flowing water along the streams at an average rate is found to be of 3 cubic meters per second. Although the volume of water in rivers at a given time is small, the total volume flowing through them over a period of time is enormous. The input mainly comes from precipitation and groundwater base flow. Approximately half of the total river water inflow to the world oceans falls into the Atlantic Ocean from the Amazon, the Congo, the Orinoco, and the Parana rivers. Least amount of rainwater flows into the Arctic Ocean. Water as ice and snow. The fresh water available on the earth in the form of ice constitutes about 80% and is 2% from the world's total water resource. Most of these are located in the great glaciers that cover the North America and the Greenland, the Antarctica, Asia, and Europe. Ice within glaciers moves slowly towards the margins and it gets melted. Snowfall over an area is more uniform than rainfall. Snow accumulation is largely a function of elevation, slope, exposure, and vegetative cover. The total snow cover of the earth is 72 million square kilometers. Sea ice is 26 million square kilometers. Ground ice is 32 million square kilometers. Glaciers and ice sheets cover about 16 million square kilometers, and icebergs is about 63 million square kilometers. The atmospheric ice alone covers an area of 510 million square kilometers. The residence time of glaciers may be for thousands or even millions of years. The melting of ice from glaciers will have a major role to play in rising the water level of oceans. If the existing glaciers melt completely, the oceans would increase to about 2% and the sea level would rise about 100 meters. The following table shows the distribution of water as glaciers and ice across the globe. Water in lakes. Lakes constitute about 0.017% of the world's water resources. More than half of this is held in freshwater lakes and the rest is in saline lakes. Almost 75% of the total volume of freshwater lakes are found in North America, USSR, and East Africa. Lakes occupy about 1.8% of the Earth's surface. Almost 304 million standing water bodies are existing in the world. Small lakes are more in number. About 60% of the world's lakes are in Canada. Finland is known as the land of 100,000 lakes. The Caspian Sea is one of the largest saline lakes in the world. It has a water residence time of 200 years. For freshwater lakes, the residence time is as low as 90 years. Lakes provide an important source of water for irrigation and domestic water supply. Local climate is also controlled by lakes. Water as soil moisture. The soil matrix and the geologic materials, that is rock and sediments, have some amount of empty space in them. This empty space is called as the pore space. The percentage of pore space by a volume in a rock or sediment is called as the porosity. Within all naturally occurring geologic units, the pore space always contains some amount of moisture. If it is seen in soils, it is called as soil moisture. The soil moisture is the term applied to the water held in the soil by means of molecular attraction. Water forms a thin film around the soil particles and fills up the small pore spaces of the soil particles. Soil moisture accounts for about 0.005% of the world's water masses. This is the major source for all vegetation to survive. The average residence time of water in the soils is about 1 month. The amount of moisture present in soils differ with reference to the physico-chemical properties of soils, the climatological factors of the area, and geomorphic conditions. It is also varying over croplands and agricultural regions. Groundwater as a source. Groundwater is one of the important reservoirs of water on Earth. It is the water stored in the pore spaces of subsurface geological formations. The subsurface or vertical distribution of groundwater is divided into two zones as zones of aeration and saturation. The zone of aeration consists of interstitial openings that are occupied partially by water and partially by air. In the zone of saturation, all the interstitial spaces are filled with water under hydrostatic pressure. It is also a fact that on most parts of the land masses of the earth, a single zone of aeration overlies a single zone of saturation and extends upward to the ground surface. The depth of the aquifer also goes into several hundred meters below the surface. The occurrence, distribution, and movement of groundwater depends on the hydrological properties of the geological formations. The hydraulic properties of soils and rocks depend on the sizes and shapes of the void spaces. These may vary over very short distances. The water-bearing geological formations are called as aquifers. Groundwater gets replenished through natural recharge from rainfall. This system supplies water for a major portion of population all over the world. This resource gets depleted due to overexploitation. Springs are seepages coming out when groundwater touches the surface. Groundwater has its own residence time. The residence time of groundwater depends on several factors, including seasonal inputs from rainfall and output as base flow. The base flow consists of water that infiltrates into the ground during and after a rainstorm. It also relates to the sustaining stream flow during dry periods and between storm flows. The source of base flow is the groundwater that flows through unsaturated and saturated soils and cracks or layers in bedrock or other impermeable layers adjacent to the stream. Water in living organisms. Water and life go hand in hand. The total amount of water stored in the living organisms is extremely small when compared with the other reservoirs. Plants play a dominant role in utilizing the water and release it back to the atmosphere. Life is tied up with water, air, and food, while food is tied to water. Though water is a regional resource, its shortage is becoming a global issue due to increasing population, economic growth, and climate change. The residence time of water is also very short. It ranges from a few hours in warm-blooded animals to a season for most plants. Development of new sources of water, besides its efficient use, together with conservation measures, should be an important component of any country's national water resources development plan. Water balance equation. The water balance equation provides a quantitative means of evaluating the hydrologic cycle and the world's water masses. The equation considers the inflow, outflow, and changes in storage as inflow equals outflow plus or minus changes in storage. This equation can be expanded as P minus E minus T minus RO equals delta S, where P equals precipitation, E equals evaporation, T equals transpiration, RO equals runoff, delta S equals changes in storage. This equation balances the water availability for a specific time period. Human pressure on water resources. According to the assessment made by the United Nations on world's water resources, the available water resources globally are found to be continuously declining as a result of excessive withdrawal of both surface and groundwater. It has also contributed for the decreased water runoff due to reduced precipitation and increased evaporation. This comes due to global warming. Already in many parts of the world, such as West Asia, the Indo-Gangetic Plain in India, the North China Plain, and the High Plains in North America, human water use exceeds the annual average water replenishment. Use of fresh water for agriculture, industry, and energy has increased markedly over the last 50 years. More seriously, over 2.8 billion people in 48 countries will face water stress by 2025 based on United Nations medium population projections. There are more than 45,000 large dams in 140 countries. About two-thirds of these dams are in the developing world, with half present in China. These dams, with an estimated potential storage volume of 8,400 cubic kilometers, impound about 14% of global runoff as estimated by Smarty and others in 1997. The new dam construction is limited largely to the developing regions, particularly Asia. To enhance international cooperation in addressing the exploitation and degradation of water resources, The United Nations proclaimed 2005 to 2015 as the International Decade for Action, Water for Life. A major challenge is focusing attention on action-oriented activities and policies directed to sustainable management of the quantity and quality of water resources in the world. Shortage of water. It has been found that there are 5 major drivers demanding a huge expansion of water resources in the 20th century. They are population growth, industrial development, expansion of irrigated agriculture, massive urbanization, and rising standards of living. Almost 20% of the world's population, or more than 1 billion people, lack access to safe drinking water. Water is a carrier of disease vectors. Contaminated water can cause a host of waterborne diseases. About 80% of all illnesses and more than 1/3 of all deaths in developing countries are related to water. Almost 1.1 billion people have no clean water. Their distribution is as follows: 406 million people in East Asia and the Pacific, 229 million people in South Asia, 314 million people in Sub-Saharan Africa, 38 million people in the Middle East, 49 million people in Latin America and the Caribbean. Today, some of the world's biggest cities, including Beijing, Buenos Aires, Dhaka, Lima, and Mexico City, depend heavily on groundwater for their water supply. The current overuse is not sustainable because it takes many years to fill aquifers. It is also a fact that most of the world's megacities are located along the coastlines. In these regions, the aquifer depletion leads to saltwater intrusion and the contamination of freshwater resources. Quality of water. In addition to quantity of water, the quality of water available on the earth is also a very significant aspect to be understood. The physico-chemical and biological properties of water determines the quality of water for its suitability for drinking, domestic, industrial and irrigational purposes. The quality of water deteriorates due to contamination or pollution and due to various mixing processes. Water quality is affected by chemical, microbiological and thermal pollution. The chemical contamination comes due to excess nutrients, acidification, salinity, heavy metals and other trace elements, persistent organic pollutants and changes in sediment loads. The microbiological contaminants, bacteria, viruses and protozoa in water pose one of the leading global human health hazards. The altering natural water temperature cycles can also impair the biological functions that can affect the metabolic rates in aquatic organisms, leading to long-term population declines. Water pollution is a new problem approaching crisis levels in many parts of the world. Polluted water is a major cause of death and disease in the developing world. Water becomes unsuitable if contaminated with toxic substances. It is a fact that half of the world's rivers and lakes are seriously polluted. Importance of world's water. If the water from land frontiers did not return back to the seas and oceans from precipitation and runoff, then the sea level would drop to about 1 meter per year. The salinity would also rise and rate of evaporation gets reduced. In such cases, all the oceans would be completely dry within 4,000 years. It will take 30,000 years to fill these oceans again through runoff. Water is the Earth's primary integrating medium. It has a wide potential to reduce poverty, increase food security, improve human health, contribute to sustainable energy sources, and strengthen the ecosystem's integrity and sustainability. These water-related goods and services represent a very significant amount of opportunities for sustainable development. This has also been recognized in the Millennium Declaration and at the recent World Summit on Sustainable Development. Water use is uneven across countries. The 10 largest water users in the world in volume are India, China, the United States, Pakistan, Japan, Thailand, Indonesia, Bangladesh, Mexico, and the Russian Federation. Agriculture is by far the main user of water. Irrigated agriculture accounts for 70% of water withdrawals, which can rise to more than 90% in some regions. Global water management concepts. The report on the findings of Phase 1 of the UNESCO WWAP Water Scenarios Project to 2050 shows the importance of global water management options. It has been concluded that global water management has to address two fundamental categories of uncertainty. The first one is related to water supply, which is dependent on the geophysical parameters that dictate water availability, precipitation, runoff, infiltration, etc., as well as on the impacts of human activities that affect the natural flow of water. Example, how land use affects stormwater runoff and water quality. Conventional analysis of historical data, coupled with stochastic analysis until now, has provided a fairly good basis for examining extremes in sensitivities, robustness, resilience, and reliability under past climate variability. For water managers, this is the starting point for any realistic analysis, and these kinds of analyses are being done routinely in most managed systems. The second category of uncertainties relates to variability and the rate of growth in water demands. The number and intricacy of choices seem to be growing beyond leaders' abilities to analyze and make decisions. For example, unforeseeable trends in the rising demand for all goods and services, including energy, affect water in some way through production, transport, or disposal. This creates new uncertainties and associated risks for water managers. Developing countries like India are actively being encouraged to move from the traditional supply-side orientation towards proactive demand management under the broad framework of Integrated Water Resources Management, IWRM. Integrated Water Resources Management, IWRM, is a sound philosophy which is hard to disagree with. Conclusion. Water is the source of life and development on our planet. Reliable assessment of the Earth's water is very difficult due to the dynamic nature and hydrologic variability of water in time and space. Allied problems exist in estimating global population and total annual renewable freshwater availability internationally. Water problem assessment is a major subject of study. It comprises reliable assessment of water availability, water quality, water needs, and water shortage. A thorough knowledge of the physical distribution of water is needed to solve many problems of the world in relation of water resource management. Water conservation technologies, for example, are slowly becoming more prevalent and can help reduce water use. The world is not running out of water, but it is not always available when and where people need it. Climate, normal seasonal variations, droughts and floods can all contribute to local extreme conditions. Water is not in short supply over the earth. It is a duty to conserve the available water resources of the world. The hydrosphere is an important environmental segment of the earth. It is an essential segment for all life to survive. Summary. Water is the most precious gift of Mother Nature. Hydrology is the scientific study of the origin, occurrence, properties, distribution, and effects of water on the Earth's surface, in the soil, and in the underlying rocks, and also in the atmosphere. Earth is probably the only planet containing plenty of water on its surface. Water is unevenly distributed in almost all parts of the world. The origin of water on Earth dates back to several million years. The term hydrosphere refers to the sphere of water on Earth. The Earth has about 1.386 billion cubic kilometers of water. In this, about 97% lies in the form of seas and oceans containing salt water. More than 2% exists as ice caps and glaciers, and about 1% is spread in the form of rivers, lakes, groundwater, and water vapor. Only 3% of the water available on Earth is fresh water. Studying the world's water is an essential part in dealing with the issues of water resources management. In this module, the importance and properties of water, the presence of water in all spheres of the earth, the cyclic movements of water, the nature of water present in various reservoirs, the concept of water balance equation, and the quality aspects of water have been explained. The pressure of humans on world's water masses is also pointed out.